Assalamualaikum. My name is Zaira Nasrimati Muhammad Najib. My metric number is 23F1011. Today we want to present about DCC 40142 Steel Structure Design, which is a design project presented by Group 1. This is our team members. We have four members, which is first Nurul Ayuni Nabila, second Zuhaira Nasrin, it's me, and third is Roxana Amira, and fourth is Nur Laila. We move to introduction, which is the design project focused on the development of the single throw reef steel framing structure carried out in accordance with the requirements and design principle outlined in Euro Code 3 NZ 1993. The primary objective to design and analyze steel beams that are structurally capable of safely withstanding the applied loads while maintaining efficiency and economy. Structure design involves not only the selection and verification of suitable beams section but also the comprehensive evaluation of their performance under expected service condition. This include calculation for bending, shear and deflection using established design standard and technical methods. The aim is to ensure the design structures is safe, serviceable, and resource efficient while also being constructible with commonly used material and methods. Emphasis is placed using Eurocode 3 not only as a design standard but also as a decision making, ensuring compliance, performance, and material optimization. Okay, we move to the introduction design beam, which is this project involved the design of structural steel beams for a single story framing building, following the guidelines established by Eurocode 3 and 1993 for the design of steel structure. The focus on the analysis and design of fully restrained beam members, ensuring that they perform safely and efficiently under applied loads while complying with modern engineering standards. The structural layout consists of a grid system defined by columns at intersection level A to D and 1 to 3, forming multiple rectangular bays with varying beam span. The beams will be analyzed for bending, shear, and deflection to ensure that they meet the structural performance criteria under both ultimate and serviceability limit state. For the design, all beams are specified as 762 times 267 times 147 UB section fabrication grade structural steel, which has a yield strength of 235 MPa. These properties making suitable for medium span application, offering a balance of strength and materials. This is a design of beam, which is for first is right view and top view, 3D view and front view. For summary of design beam is in conclusion, the beam design project has been a comprehensive application of structural engineering principle to real life scenarios. Through detailed analysis and calculation, each beam was carefully designed with withstand expert loads, ensuring the overall safety of the structure. The beam design given is 762 times 267 times 147 universal beam UB with S235 grade steel. The shape of the dimension of the web and flange classify the beam as class 1, which allows to resist bending without significant lateral buckling or yielding. The design results show that both shear force and bending moment values are lower than their respective resistance capacities, confirming that the beam's shear and bending resistance are adequate. Since the beam is fully restrained, it is not susceptible to lateral tensional buckling. Moreover, as the imposed load Qk is zero, the actual beam deflection is also zero. Therefore, the selected beam section is considered acceptable and satisfied for design project.
Assalamualaikum and good afternoon. So my name is Nurlaila binti Mahaso and my matrix number is 17 DKA 23F1075. So I will present about design column. So for the introduction, the one-story building for column design consists of 12 columns arranged in a grid layout from A to D rows and 1, 2, 3 columns. Each column has a height of 4 meters and use the same section, which is 365 times 406 and times 551 UC, made from S235 steel grade. Although the column size and material are uniform, each column carries a different axial load depending on its location in the layout. This load difference required that the columns be grouped into 8 types to ensure accurate and safe design according to their respective load combination. The Asian loads acting on the columns are as follows, which is A1 equal to 2.68 kilonewton, A2 equal to 2.66 kilonewton, A3 equal to 2.30 kilonewton, and so on, according to the slide. With this value, each column will be analyzed and designed individually despite using the same section, ensuring structural stability and compliance with relevant design standards. So this is the drawing of the design column, which is have 3D view, side view, and top view. And for the conclusion, to summarize, the column design project followed a similar approach to the beam design, applying fundamental structural engineering principles to ensure stability and safety. Each column was thoroughly analyzed and calculated to resist applied load and moment, whether from beams or other sources. The column design given employs a 365 times 406 times 551 universal column with S235 steel grade. The column's weight and flange are classified as class 1, allowing it to resist bending without experiencing significant lateral buckling or yielding. In some groups, certain columns do not exhibit bending moment due to symmetrical load distribution. All columns have the same size and height, resulting in consistent resistance capacities across the groups. Verification results show that all columns have design to resistance ratios below 1.0, indicating structural adequacy. Thus, the column section used in this single-story building are deemed acceptable and satisfied for column design. Thank you.
Hello, Assalamualaikum. My name is Uksana Mira binti Mohammed and my matric number is 17 DKA 23F1006. So, here I'm going to present about introduction of roof truss design. A single-story building is being designed using a roof truss constructed with an angle section of 200 times 150 times 12 L. The total length of the truss is 3.46 meters and it consists of 8 joints with the roof pitch at 30-degree angle. The internal force need to be determined for several members, including AB, BC, CD, DE, AF, FB, FC, FG, GC, GH, HC, HO, and HE. These calculations are essential to identify whether each member is in tension or compression, and to ensure that structural integrity of design beam. Based on the data available, the internal force in member AF is 83.94 kN in compression, while AB experienced 40 kN in tension. And it is similarly to member FG carries a compressive force of 80 kN and CG is 40 kN in tension. By calculating the force members can access whether the selected angle section is sufficient to the expected load and if the overall truss design is structurally sound. Okay, here we have a simple symmetrical roof truss design intended to support the roof structure effectively. The overall span of the truss is 11 meters and divided equally into two halves of 5.5 members each. The truss includes a triangular configuration with vertical and diagonal members to distribute load efficiently. The height at the center of the truss is 35 units, um, and the vertical supports of both ends are 17.5 kN in height. Each top chord is sloped symmetrically with equal dimensions, and the design ensures that the load is evenly transferred from the ridge to the support. The central vertical member and the diagonal web members enhance the stability and rigidity of the structure. Okay, last but not least are the summary of the design roof truss. In conclusion, the roof truss design project successfully demonstrates the application of structural analysis to support the roof system using steel angle section. The roof trusses were carefully designed and verified through calculation to resist axial force resulting from external load. Members AD, AC, TF, BH, BE, and EF were analyzed under both tension and compression. For members TF and BE, the final axial compression loads were within the permissible resistance, indicating adequate performance. However, member AD and AC recorded axial tension loads that exceed the design resistance, rendering these members structurally inadequate. The failure in these cases was a- attributed to the use of oversized bolt diameters, which reduced the effective net area. This highlights the importance of selecting appropriate connection details to ensure overall truss performance. Therefore, while most members meet the design criteria, some sections required revision to be considered fully acceptable and satisfied. Thank you. Ooh.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Ayuni Nabila, and I'm gonna introduce about design connections. So the beam to column connections in the structure are to be designed using welded joints. These welded connections are required at several locations from beam 1 AB to column A1, beam A12 to column A2, beam 1 BA to column B1, beam 1 BC to column B1, beam 1 CB to column C1, beam C12 to column C1, beam 1 CD to column D1, and beam D12 to column D1. For these design tasks, a person will evaluate the connections initial to determine whether the design is structural acceptable. The design shear force VED varies depending on the specific column being analyzed. In this assessment, a fillet weld with a thickness of 4 mm is used and the effective weld length LW is kept constant at 300 millimeters. So the goal is to verify whether the selected weld size and the length provide strength to resist the applied forces, ensuring the adequacy of the connections. So for this slide, is summary of design connections. In sum up, the connection design project using welded is one of the ways to connect one structure to another by applying engineering principles, by carefully analyzing and calculating. Each connection was meticulously crafted to withstand expected loads and movement, whether the load from the beam or any other action, to ensure the safety of the structure. For calculation, connection design has been chosen is using welded connections. So the higher the value of the welded area, the stronger the connection can support any load, but the cost will be more costly. After calculate the size of fillet weld for this connection, design design that's suitable to use, which is 20 millimeter diameter. It's already suitable for this project because shift was due to out of plane movement. Value is a way higher than vector sum of first value. In conclusion, the connection design for the single story building need welded connection to resist any failure. So for the last slide is about the conclusions. So the conclusion is this project involved the structural design of steel frame building uh, to focusing on the main elements such as beams, columns, roof truss, and connections. Using Eurogrid 3 as the design standard, each component was analyzed and designed to ensure safety, strength, stability, the project provide a practical understanding of how these structural parts work together in a complete system and help develop essentials skills in applying engineering principles to real world steel structure design.